this is our project, soldering, reflow oven for soldering SMD components, and our group is Tuesday 12, and I'm Sameep Chattopadhyay.
I'm Amruta Parulekar.
I'm Anmol. And this is the hardware that we have here. So SMD components, as you can see, are very small, and it is almost impossible. It takes a lot of time to solder them with that soldering iron and the wires. So there is an alternate way of soldering that uses this soldering paste. So what it is done is we take the PCB, and onto that the soldering paste is put. This soldering paste is put onto this PCB, and on that the SMD components are placed. Now, for the SMD components to get stuck to the PCB, it has to follow a very specific temperature curve. That is, so a very specific temperature curve has to be followed, where it is first heated, then the temperature has to be maintained to at a certain level for 2-3 minutes, and then the temperature rises and it cools down very fast. So our oven basically does that. It takes the height, it takes the input in form of the maximum temperature, and then it heats it for one minute, and the constant temperature is maintained for some. For that, during that time, we are using a PID controller, through which it controls the timing of switching on and off of the temperature, this heating element, so that the temperature is maintained. This is the heating element that we have. The heating element that has been placed between the two mica sheets, and then there is a copper plate on top of it. The heating element is composed of nichrome wire, and it can go up to 300 degrees Celsius.
So the structure of this is the structure. Basically, you have a nichrome wire. This is the structure of our oven. Basically, you have a nichrome wire which is coiled, and it is sandwiched between two mica sheets. On top of that, you have a thick copper plate which has a high specific heat to retain the heat, and it is screwed using 4 screws to a wooden platform in the center. We use wood because acrylic will melt. The top surface is also wood because it's very close to the heating element, so it can get affected by the heat. At the back, we have slits for air to enter, and on the sides we have fans. So when it's in the cooling process, the air enters through the slits and leaves through the fans, and the temperature drops. At this point, the heating element will be turned off. We have a control panel in the front, which has an LCD display which continuously displays the temperature and the mode, and a keypad where you enter the temperature.
This is a high power circuit. So what we are using is an SMPS device. This using the AC power supply, it converts it down to 12 volt DC, and using the 12 volt DC, we are converting it down to 5 volts, which is powering the microcontroller, and the 12 volts are directly going into the nichrome wire, which is used for heating the plate. So this is the whole electrical circuit, and for the temperature control, for the first 1 to 1.5 minutes, it is the temperature is risen to 150 degrees. It is kept constant for 1 minute to at 150 degrees, and finally it is risen to the maximum temperature of around 200 degrees and dropped instantly.